Hello. Today we're going to take a look at importing an STL mesh into SpaceClaim, and we're doing a fairly specific application here where we're going to take the STL mesh, translate the coordinate system, and then export it back out so that we can use that geometry that's been translated into a different location. So we'll do this fairly quickly. It's a pretty easy task to do. We're not going to use the features on this part. We're going to treat this as strictly an organic surface. When I say organic surface, what I mean by that is something that's not prismatic CAD data. We're not dealing with cylinders or planes or any sort of boss of that nature. We're dealing with lofted surfaces or things more of that manner. You would consider it something like a NURBS model or whatnot. With this STL mesh, of course, it's all organic. It's all triangular faces, but we could come in, create CAD off of it, and then translate it in that manner. But we're just going to consider this as strictly an organic surface. So to move it, we'll simply come in, press move, select our mesh, and now I'm going to use this ball and I'm going to translate this ball all the way out onto the corner of this part because that's where I want my coordinate system to be. You may want it to be somewhere in a different area. This is just my preference for now. So what we're going to do first is, because I have that sitting there, we're going to translate this to our 0, 0, 0. So our X, Y, and Z is all 0. So now we've moved this specifically to our 0, 0, 0 origin on our coordinate system. And we also have our X positive facing in this direction and our Y positive facing down in this direction. Say we want to move that also. So what we can do is, there's a few different ways we can translate it. But again, if we have this out at the corner, now that we're already moved all the way out to our 0, 0, all we have to do is translate this, let's say 180 degrees. Okay, so now our X positive is in this direction, our Y positive is in this direction, which we can see by our coordinate system indicated down here in the bottom left hand corner of SpaceClaim. From here, we'll go ahead and get out of this function, and we will save this off as an STL mesh. So we're going to call this prop2. Okay, so we're also going to change this to an STL file so we can read this directly inside of Geomagic fairly easily. We'll let it export out, and then once we've done this, we'll take a look at the model inside of Geomagic to see the translation. Okay, so we'll grab Geomagic and we'll import prop2 STL. Okay, so once we do this, we'll see it come in. And another thing to note is, while things have been a little laggy through this demonstration, we can also see that this original file was close to 6.5 million points, which is what we were working with directly inside of SpaceClaim, which is fairly impressive. While we did notice it was fairly laggy, we still have the capabilities to use quite a large number of triangulated mesh faces directly inside of SpaceClaim. So that's just one thing to note. Alright, now we'll go ahead and tell it no, we do not want to use Mesh Doctor. And then if we look at our model, we can see, and it's a little difficult to tell, but our prop 2, which we can see over here, is now lined up directly with our coordinate system as opposed to the original file that was shifted off. So I hope that this has been informative, and if you have any further questions, feel free to contact us at www.gomeasure3d.com or by phone at 434-946-9125. Thank you and have a great day.